We are going to discuss about the manufacturing process of engine block. Myself is Aman Bashir Satarmekar from Rajaram Bapu Institute of Technology from Islampur. My PNR number is 22566020. Engine block. The engine block is a single unit that contains all the pieces for all the engine. The block serves as the structural framework of the engine and carries the mounting pad by which the engine is supported by the chassis. The engine block is manufactured to withstand large amount of stress and high temperature. This is the actual diagram of engine block. Functional requirements of block. Engine block are critical component of an engine. It must satisfy a number of functional requirements. Some requirements include lasting the life of vehicle, housing internal moving parts and fluids, service and maintenance, withstand pressure created by the combustion process. Required material properties of engine block: high strength, high fatigue strength, high modulus of elasticity, corrosion resistance, low thermal expansion coefficient, optimized thermal conductivity, and last one is low density. These are the required material properties as per the condition. High strength is a particular concern in diesel engines since compression ratio are normally 7:1 or higher as compared to conventional engine. The material should also have low density, low thermal expansion, low thermal conductivity. Based on the listed requirement, industry have used cast iron and aluminum alloys to manufacture the engine blocks. The material used for engine block is mainly cast iron. In cast iron, grey cast iron alloy have been dominant metal that was used to manufacture convenient gas-powered engine blocks. Grey cast iron typically contain 2.5 to 4 weight% of carbon, 1 to 3 weight% of silicon, 0.2 to 1 weight% of manganese, 0.02 to 0.25 weight% of sulfur, and 0.02 to 1 weight% of phosphorus. Advantage: it has excellent damping capacity, good wear and temperature resistance, is easily machinable and inexpensive to produce. Disadvantage: they are relatively weak and frame and deformation. Compacted graphite cast iron. Compacted graphite cast iron, which was accidentally discovered while trying to produce ductile cast iron, higher tensile strength and elastic modulus than grey cast iron. This is a comparison between grey cast iron and compact graphite iron. Aluminum alloys. Aluminum alloys was discovered to reduce the overall weight of the vehicle. There are two practical implications: increased fuel efficiency, improved performance to the weight ratio. The drawback of using aluminum in engine blocks are that are more expensive to manufacture than the cast iron alloys. This is a comparison between two aluminum alloys. The tensile strength of first aluminum alloy is 178 and the second one is 215, and modulus of elasticity is 74 and the second one is 72.4. Tooling required for casting engine block. The main tool needed for cast iron is the mold. The mold is generally generated by the mixture of sand, clay and water. The pattern is the main tool required to form the mold. It is normally machined by the wood or aluminum, which can be easily machined. Casting process. The manufacturing of engine block are mainly done using the sand casting or die casting, also used in more cost effective as a die mold making. In the sand casting process, the widely used in the engine block casting is green cast mold casting. The term green denotes the presence of moisture in the sand mold. A combustion of silica, sand, clay and water are poured into one half of the aluminum block pattern with wood or metal frame. This process is repeated for the other half of the mold. Then both halves of the mold are removed from the pattern. This is the actual mold diagram. Casting process. Core making. Then the next process is core making. Core making is the process which forms the interior part of the casting. The mold provides a space or molten metal to go, while the core keeps the metal from filling the entire space. Core can be used to extend mold projection to create extra mold section or block out and create the negative drafts. This is a core making process. And the next is mold arrangement. The water jackets and cylinder molds are arranged in the main mold as one cube. The mold is then tight using cams to pressure of the gravity when pouring molten metal. And the last one is pouring of molten metal. Now the mold is ready for casting. The molten metal is poured into the mold through the smaller front center hole, which fills the mold from the bottom back up to the top through the risers, which can be seen as 8 large holes. Then machining and finalization of product. The rough aluminum block casting is shown above. After the removal of sand, mold and the sand is removed by applying vibrating on the casting. The casting has to be machined to get correct dimension and smooth surface of the engine block. This is the finishing and machining after the cast. Quality consideration during the operation. During the production, the quality of the sand used widely affects the surface finish of the engine block. The sand should contain these features to get the required finish. The strength of the sand has to be high to maintain a rigid shape. The permeability of the sand grains must be maximum. The thermal stability of the mold should be high to resist the damage. The ability of the sand to compress during solidification has to be high, unless the casting will not be able to shrink freely in the mold and it may result in cracking. The sand has to be formed because one sand mold can be only once used. Possible defects during this process. If the permeability of the sand used for casting is high, the strength and the surface finish of the mold will be reduced. If the thermal stability of the sand is low, the mold may crack due to molten metal. If the riser gets solidified before the other parts of the casting, it would give an engine. If the molten alloy is not to be standard, it will failure in high running condition. Thank you.